Hello and welcome to the TTI Distribution Download, the podcast where we talk about all things happening in the world of electronic components with the specialists of TTI. And now, your host for the TTI Distribution Download, Paula Renfrow.
Thanks, Jim, and hey, everybody. Thanks for plugging into the TTI Distribution Download. This episode 3 of our Nexperia Battery Life Booster series, we welcome back Senior Technical Applications Manager at Nexperia, Tom Wolf. And joining me in the booth is TTI Director of Technical Marketing, Pat Denton. Thank you, gentlemen, for sticking around and for really wrapping this topic up for our listeners with applications and use cases. I appreciate it.
Thanks. Great to be back.
Pat, would you level set us again one more time with why this technology is valuable?
Sure. Extending a coin cell battery's working life significantly reduces battery waste in low-power IoT and other portable applications while making coin cells a viable power source for applications which could previously only operate from AA or AAA type batteries. Mm-hmm. Tom, let's go into some real-life applications for this Nexperia solution.
Okay. When you hear the word battery booster, the mistaken belief might be, oh, it will make my battery last longer in every single application. It's a wonder. That's not what it does. Remember, it is an application-specific solution device. It is really built to solve one particular type of problem that are used with coin cells. So the applications we're looking for are where you're using a coin cell in a mode where you want to draw a lot of current out of it very quickly, something that, again, the battery doesn't want to do in the first place. So it is those types of things in IoT applications. Again, it's going to be transmission, pulse mode sorts of things. So things like, e-meters and monitors and alarm sensors and key fobs, those are the ideal applications. But if you go back to like some of the other applications that coin cells are used for, for backing up the real-time clock on your ancient IBM PC compatible machine, it's worthless. Matter of fact, it doesn't do it probably hurts in the long run because you're not using it for that. So you really want to look at your application and say, hey, am I using this battery in this particular mode? Now it's perfect. So to put some numbers around that, I want to draw power out of a coin cell battery at a couple of milliamps. When I get up to around 10 milliamps, that's when I start damaging the battery. So if my application needs more than 10 milliamps and maybe up to 200 milliamps to transmit my RF energy, that's the sweet spot. That's where you want to use this. If you're trying to arc weld with a battery, forget it. This thing is not meant for that. So it's kind of that space which is really ideally suited for, again, RF type of transmissions in a small handheld device on a coin cell. That's what it's aimed for.
Okay. So those are the applications that they're good for. Maybe more importantly, what applications is this not good for?
And that kind of is the summary again, is that, like I said, radio pulse applications is good for. Coin cells are used in a lot of other places. Like I said, they're still used for battery backups. They're used in a lot of toys and games and stuff, for blinking a light or something. There's no value in it for those types of things. So again, look for pulse mode applications. That's the key where this device really works at. So the most obvious one then is your key fob for your car. Everybody uses them now, and there's more and more features being added onto it. Perfect application. That key fob, it's not big enough to put AA or AAA batteries in it. It'd be a big lump in your pocket. So the coin cell is the perfect physical form factor, but you want to use it in a pulse mode. So that really is like one of the perfect types of applications for it, the electronic key fobs. But again, other places would be things like security systems where I need to transmit data, temperature up in a building or types of things like that. Those are the perfect applications for it.
Do you have an example? Have you seen like a really creative way an engineer has applied this technology? Something that really made you think, oh, well, that was smart.
All of them are the same types of things, but the environments you can put them into. One company, for example, does they do mining, coal mining, and they wanted to have motion sensors down below to see if people were in the mine or if there were collapses or something like that. Well, once you put this monitor down in the coal mine, you may lose it after a while. So they're kind of like disposable. So they go, I want the battery to last forever on it because once it's gone, I'm never going to find the sensor anyway. So it was an ideal type of application where you need maximum lifetime out of the battery and it needs to work. And then I can literally throw it away when I get done with it. The cost savings of the safety that I gain from it is very useful. So this allows you to make very low cost sensitive types of sensors in IoT. Imagine what you could do with it if you had a temperature sensor, a fire sensor, a gas sensor, a flammable gas sensor, all different types of things in a factory or an office environment. Very small, very cost effective, yet they can provide really powerful data out to the rest of the system for security and safety and types of things like that. So really good applications in that world.
Mm-hmm.
Yeah. So, Tom, how would I or maybe one of the listeners determine if I had an ideal application?
Well, there's kind of two ways of looking at it. We've sort of described the technical merits for it. If you've got a system where you've got really small form factor, I want to put a coin cell in there because of the size and the energy density, but I want to run in a pulse mode type of application, you're pretty close right there in the first place. Now, how long are you actually going to get out of it? We say we designed it for 10x the life. Do you believe me or not? Well, this is where the evaluation board would come in. So get a hold of the evaluation board, put the coin cell onto it, program it up, and play around with the parameters because there's a lot of adjustments to the device itself. What current do you want to pull out of the coin cell in the first place? What is the output voltage you need on it? What is the amount of current that you want to send on the output side of it? Do you want to send alarms at a particular point? So you can play around with a lot of variables on the device and see how it works in your real world application. The good news is that most of the people that have played with it already are saying, yeah, I'm getting 8 to 10 times the lifetime out of the battery. Remember, it's not just the cost of the battery you're saving here. It is the cost of the entire system replacement. That technician that has to drive out and change the battery because it died, you want to save that as well too. But we're also seeing people where they want to build a design which just is more convenient. For example, a key fob for an inexpensive car, they would just leave it up to the user to say, fine, it's going to eat batteries once a month. You're paying for the batteries, user, you have to change them yourself, no battery booster for you. For a high-end car, that might not go over very well. And so you could sell it into a key fob for a high-end application where you can say, you don't have to change the battery in your key fob for your Ferrari for a year because the battery lasts that long. So there's a lot of variables you could put into this. Again, the idea is to get rid of the number of coin cells that we go through and destroy and throw away. But you can also add in the value of the convenience of not having to change it, or the real system cost, the real cost of not having to have that technician drive out and climb up a ladder and go up in the ceiling and find where he hid this sensor and replace the battery in it. There's real cost savings in that. So don't look at it as, oh, okay, instead of having to buy 10 batteries, I only have to buy one. That's not the cost savings for it. The cost is I don't have to replace 10 batteries, and the cost of replacing 10 batteries, that's really where the value, that's the ideal application for these devices.
I think our test case should be that we get a Ferrari and see if the key fob lasts longer than it does on either one of our cars. Well, that is...
I'm right there with you.
You're right there with me, yeah. Well, I think that is a wrap on this topic for now. Yes, gentlemen? Anybody? Anything I forgot to ask?
No, that's great. Thank you, Tom. Appreciate your time.
Absolutely. Thank you for the time to discuss that. It's an interesting type of technology, all put together in one place and really solves what is a really common problem in the marketplace with coin cells and small remotes. This is the device which solves that problem that everybody tries to just forget really isn't there. Now you can solve it the correct way.
You're right. In our personal lives and in industrial, of course, I knew what a coin cell battery was, and but not really quite the extent in industry that we were using them as well. We'd love to have you both back soon.
Yes, thank you, and would love to be back.
Happy to come back, talk about any topic.
And thanks to our listeners for plugging into our Nexperia battery life boosting technology series. If you'd like to talk more about how this technology can work in your design or order one of those evaluation boards that Tom talked about, Pat tells us they are on the shelf and ready to ship, just reach out to your local TTI specialist at 1-800-CALL-TTI.
That's it for this episode of the TTI Distribution Download. For more information on any of the topics you heard about today, reach out to your nearby TTI branch at 1-800-CALL-TTI or visit us online at tti.com.